So in today's example, I'll draw the basic chart, that is your line chart. And those who are not available or not there for the last session, let me tell you, we are going to make use of a new package or a new model, which is known as your matplotlib, a library which is available in Python. Now it is used along with your NumPy to give you effective, you can say, charts, which is an alternative to your MATLAB. Those who have heard about this package called MATLAB, which is basically used for your graphs and all, or your graphics, going to make use of matplotlib, which is a library available in Python. Okay. Now, there's one more toolkit, which is, or two more, you can say, which is available, which we can use, is your PyQt, PyQt, and WX Python. Okay. Now, matplotlib was written by John D. Hunter. He is the first writer, and now it has been taken over by Michael. Now, the surname is difficult to pronounce, so I'll just call it Michael here. And he's the current, you can say, developer or the principal developer of your matplotlib. The packages can be downloaded from the website at matplotlib.org. But if you have loaded Jupyter or Spider or whatever the latest versions, I think it will come along with those versions. Okay. But still, if you are getting any error, please go to this website and download the package here, especially for your matplotlib. We are going to make use of a function called pyplot. Okay, so to always, whenever you are adding your or you're importing your matplotlib or your py or pyplot, that is your Python plot, we can make use of either the import statement, directly import matplotlib.pyplot, or we can also make use of the statement from matplotlib. So today I'll just show you this statement. Last time I had shown it, so once more I can make use of from matplotlib import. Now we are going to make use of the pyplot, so pyplot, and we'll name this as an object pl. Okay, so this statement will help me, import, get pyplot from this library matplotlib. Okay, and we can plot a graph. Now, as I told you, in today's example, I'll be plotting a line graph, and I'll show you how to store it in a file. Please refer to the previous session, which I've already uploaded on the YouTube, where we have done different types of charts as well. Now, to take a very simple example, I'll take two arrays, X and Y. So let us have some values here, 2, 4, and 6. So 0, 2, 4, and 6. I'll take another array, Y. So X will be the points for your X axis. And similarly, for your Y axis, I'll have some points. Say 1, 3, 4, and let us put one more, 8. So 4 points here, 4 points there. Fine. Now, to plot a graph, we make use of PLT now, which is an object of your pyplot. So plt.plot is the function. We pass two arguments here, X, comma, Y. Okay. Now, in this particular plot or in this particular chart, I'll display the labels and the title. We'll also see one more function, which I think in the last session I did not show, that is your legend function. If I want to display the legend as well for the chart, I can do that as well. So first of all, let us put the labels. So X label is the function here. In single code, I can just put X value, X values, more than enough, PLT, Y label, Y values. Now, depending on what you're plotting, you can decide what labels you want to give. Let us give a title to this particular chart. Now, this is my line chart. I can mention line chart, and I can just put a dash, plotted X and Y values. Just a title, and then I can give the legend. Now here we have, because it's a line chart, a single line will come. So I have a single legend here. So L legend. The legend will be passed in the square brackets here, and depending on how many legends you have, you can give it in single code here. Because I have only one, I can just give say line one. So this line plus along with that, what color line is displayed will be on my chart. Now, before I'll just show you this plot on the console here. So to display the chart, I have to use the show function. So plt.show will give me the chart. Let us see this on the screen here. Okay. So this is my chart, which is displayed in the console. And you can see this is the legend here, line one. This is my title, the X values, Y values, and this is the line. Now, if I want to store this chart, the line chart, in a file, then before I actually display the chart, I have to store it in a file. The function which I'll be using here is save fig, that is figure. So plt dot save figure. Okay, there are some arguments here, but I am not going to display give you all the arguments right now. I'll give the simplest argument, that is the name of the file which I want to store it as. So in single quote, let us, because this is a line chart, I'll give line.png. Now you can store it in JPG form as well, or PNG form. I'm storing it in PNG form, and then I can run this one. So here we go. Now this is my chart on the screen because I've used .show, and by default this is my working directory, C: users there. So I need to go here and check whether I have a file stored there. So let us go and check whether this file has been stored. So under C: users del. Okay, here it is. So this is my PNG file. It has been just created, 11:59. Double click it. Okay, this is my chart. Okay. Now, even last time there was a question, how do we save it in Word? Now you can take this JPG or the PNG file, and whenever you're doing any documentation, you can insert these pictures in your documentation or your Word file so that you can prepare your documentation as well. Okay. Now, what are the different other parameters which are there, which is available for your save figure? If I want to save it, like for example, there's the second parameter. If suppose I want to change the resolution of my image, okay, then we have a parameter called DPI, which can be set to some integer value. The best is 300 DPI if you want. For your web series, if you want a smaller size files, then you should keep it to a reasonable value. Now, for a smaller file, I'll prefer keeping it for around say 72 or 100 or something like that. And for high quality images, you can go for 300. Okay, 100 is also advisable. Okay, so to keep a smaller size, please remember the DPI should be small. Next, there's another parameter, especially when we have lots of titles, legends, the labels along with the chart. If I want it to be fixed in a tightly packed in a particular image, then we have an option called bbox. So bbox underscore inches. Okay, and here we can pass a parameter type, PIGHT type. So it is going to pack all the contents of the chart tightly together in a small area or in the file. So it won't go out of the image or something like that, depending on the size of the content. Okay, so these are some few parameters. If you want, you can also try it out. And when I run this now, okay, and the file is already there in this image here. You can see this now 1201 new file has been created, and it will be the same content. Okay, hardly changes. Let us do one more. Uh, Instead of a line chart, let us create a bar chart. Last time we had done one bar chart. This time, let us create a horizontal bar chart, because in the last session, I have already given you a code of how to draw a bar chart. So to write a new file, I'll create a new file here. Let us copy this first. I'll copy some values. Okay, for bar chart, I'll create two different types of bars. So I'll keep x1 and x2 and y1, y2. Okay, so this is x1. Now I'm taking the same example which we did last time, but this time instead of drawing vertical bars, I'll draw the horizontal bars, 16 and 6. So this is my first value. Let us keep x2 equal to say 6, comma 9, comma 11. One more thing, the values, if they are matching each other, I'll just show you that as well. What happens that the style of the bar changes. And let's say 6, comma 15, comma 7. The values of y's are nothing but the height if I draw a chart. Whereas if I change it, let us to draw the chart, we use plt.bar. Okay. Now I'll show you the bar chart as well, and then we'll change it to your bar h or horizontal bars. So this x1, comma y1. There are some parameters here. Here I'm going to assign alignment. I'm going to set it to center. So align equal to, you can give in single quote center. Similarly, I'll plot the other bar as well. This time it will be x2, comma y2. And again, I'm going to align it to the center. Okay. Let us give a title, ELT, title. I'll just write bar graph. For the labels, Y label, just write axis, Y axis. And for X is remaining. And I'll display this on the screen. I'm not going to store it in the file. So if I run this one, here you can see this is my chart, and the default colors have been taken. Blue is for the first bar, the second one is uh, some orange color. If I do not want the orange color, you can also specify the color if you want. Now before align, I can give another parameter color equal to, say I'm on green, so I can give G here. Now when I run this, you can see now the color has changed. If you do not specify the color, Python will assign the colors on its own. Okay, I'll keep green here. Now, what if I want the other function, which I was telling you, it's bar h, horizontal bars. I'll just, I'll keep the values as it is and just change the function from bar to bar h. Okay. So now when I run, now you can see this values have been changed and the bars have been changed. Okay. And depending on the previous also, you can see the axis has not changed. Okay. because the values of the x-axis, y-axis remains the same. Now the height for this bar depends on the x values, the x values. Now one more thing, as I was telling you, if I make the values same, let us change this to bar again, and this is x1. Let us change this to 5. Just let me check it out first. Okay, this same, and x2 also 5, and this I'll change it to say around 10. Now see what's happening is it is overwriting it, so it's the other bar is coming up. Now if I change this value 5, 5, okay, this was 5 and 12. So this is 12. Okay. Now because it was behind this, now you can see this is single bar, and it is having two colors. So one value is up to 10 is for this x2 y2. So 10 was y2. I've changed the value of x1, and that has come to 12. So it is coming up. Okay, so if you have multicolor bars, if you want, you can also have those. Then the value of x should be the same. So I can change this to say 8, and this one is 10. Okay, if I do this, but there's a problem here, especially in case of the bar, which has been drawn after drawing the first one, it is overlapping it. Okay, so you do not get it properly. Okay, and that's the reason why we had different values of x1 and x2 as well. So please remember this small things. I'm just changing the values back to the original ones. So we had 5, we had 6, 6, 9, 12, 15, 14. This was my original bar. Now, if I want to save this, please remember, save the file. If I want to put it into a file, before you actually display the chart on the screen, you're supposed to save it to the file. If you do it afterwards, then it is not going to save the chart into the file. Okay, it will be a blank. It will create a file, but the file will be a blank one. So before showing it on the console, I need to save it. So to save it again, plc.save figure. Okay, this time as it is a bar chart, let me give this name as bar, and this time I'll save it as JPG form, comma, let us put some DPI values, DPI equal to, let us put 300, okay, and the box inches equal to, now I can run this one, okay, and when I come to my folder here, this is my bar chart now. Open it, here you get your bar chart. Clear? So these are some examples regarding how to store a chart to a file. Okay. Last time we did histogram, we did subplot. Okay, please go through that session as well. Now let us move further and do some file handling in NumPy. Now, in NumPy, if I want to store the file, how do I do that? So there are two functions which are available, the load function and the save function, which handles your binary files in NumPy. Okay, and if I want to load the contents or read the contents from the file, we also have, for the text files, we have load txt and save txt. Okay, so to handle text files, we have load txt, and to handle binary files, we have the load function. Now, to take an example, we'll try to save an array into a file and see how it works out. So I'll take an example of I'll just create a simple 1D array. Before that, let us import NumPy as np. Okay, I'll create an array A equal to np.array. And in this, I am going to just create for N5. Okay. So I have 5 values in this. Now to store this file, we use the save function np.save. Okay. And in the round brackets, the only thing I'm going to specify here is the name of the file. Okay. So the name of the file here, let us give it as out file or output file, whatever you want. Okay, I'm not giving any extension. So a binary file will be created. Okay, and I'll give A here. Okay, your A indicates now in this case it will be a binary file. Okay, so let us run this file and check it out whether this file is creating properly or not. Okay, let us go to the folder and check whether we have output file. Here it is. So here we have a binary file, and by default the extension you can see this is NPY. Okay, and the size is 1K. If I double click it, let us check whether it is able to open. It won't open here because it's a binary. It's not a text file. So I have to read this file from the program itself. To do that, what I'll do is I'll read this content. So I can use the function as save function or load function. So let us load this back in a different array. So I think B and make use of B equal to np dot load. Load is the function to read the content from this file, and the name of my file is in single quotes out file. Okay. And it's a binary one. I mentioned and sorry, I can not here. I can give the extension dot np. Okay. So while reading the file, I'm using the extension, and let us print the content. Check whether the values which we had stored in this file, out file, whether they are getting displayed. Here we go. So here is the value 1, 2, 3, 4, 5, which we had stored in the array. Let us quickly make some changes in this. Let us add 167, run it again, and check whether 67. Yes, it is. So you're getting all the contents. Okay. Now, if I want to store it in the text form, the only change here will be the name of the function. Instead of save, it will be save txt. That's the function. And this time, instead of without giving the extension, previously I had given the without the extension, save was creating a binary file. Now I'll create a text file. Okay, and I'll also load it back. So instead of npy, I can give txt. It'll work out the same way like in the previous case. Okay, there's some error here, cannot load file containing. So there's some issues here. Let us check it out what has happened. Let us now take this. I'll just mark this as comment right now. Check whether the file is getting created first. So, and I'll change the name as well. Let us put this as out. Okay, there's some again positional missing one. Okay, there's this parameter X is missing. Okay, the file is created. Let us go and check whether we have here we have out. Double click this. What the hell? Okay, it is still opening. Here we go. Now this is some numbers. Now what is this? 1, 2, 3, 4, 5, 6. Now this is 67, but y 6.7. And okay, here we have e plus 0, 1. So this is 67. Fine. So when I read this now, let me read this file. So I hope now it reads the file properly and displays it. Okay, one more. The error was, let us change the name. We are supposed to read using the function load txt and not load. Load is the function which is used for binary files and not for txt files. So now I think it should work out. Here we go. Okay. Now the only difference in the previous case, even though we had integer values while storing in the text form, it has added the decimal values, and here you can see the output is also in the decimal form or the float form. Okay, that's the basic difference. So these are the two functions, and as you know, in NumPy, the majority of the programs, wherever we have NumPy, will be storing the numbers or the arrays into the file. So these are basic two functions which you can make use of in Python to store the array or to store the array in your files, whether it's a binary or your text file, depends on your requirement. Now let us go ahead. Let us check what we have remaining. Okay, let's create another file. Now there is a very important concept of data cleansing, okay, which is very important whenever we are handling files or we are reading contents from the file. Usually, missing data is always a big problem, you know, in because whenever we are doing any type of a survey, okay, usually what happens, not everyone is going to provide all the information. Okay, so in areas like machine learning or data mining, the majority of the problems or the major problem is about the data which is been used, especially the missing data. So how do we handle such missing data through Python? So let us take one simple example. First of all, remember whenever you're doing any, you can say analysis or you can take collect a data from the user. The first thing you're going to do is you're going to check whether the data is proper or not. Okay. To do that, there are a few steps which you need to follow. To give an example, the first example I'll give you is about the NA values, okay, or values which are not there. Usually you'll find them lots of numbers are there, not a number. NaN is the term, or NA is also another term which might be coming in the data. So I'll just create a small, program where we'll create a data frame with some random numbers in it, and we will check how this missing data looks like. To take an example, first of all, I'll be importing the package, the module, pandas and NumPy together. So I'll have two import statements here. So I'll import pandas as, let us say, PD, okay, and I'll also import NumPy as NP. Okay, let us create a data frame. So I'll use df as the object name, pd dot data frame. Now data frame, here we go. Data frames are nothing but you can say collections of rows and columns, you know. So basically, whenever we are reading data from whether it's a CSV file or an Excel file, okay, your rows and columns, we can always create a data frame, access the file, read the contents, and store it in the data frame. And whatever, you know, manipulations or any operations which you want to do on that particular data frame, you can do that and see the outcome. Okay, so let us create one by using the random function. So I'm going to create some numbers. Np dot random, okay, dot rand n. It's a function which will give me some standard normal distribution. It returns a sample. It is that is passed to parameters 5,3, and I'll give the indexes for index equal to. Let us give some single characters. Let us say A, then B, or let us miss on someone so that we can take an example C and T, F, N, because I require 5 of them. So let us put another one, F, N, H. H. Okay, so 5 indexes. The columns I can give as columns equal to say 1, 2, 3. I can give and one, 3 columns, 2, and okay. Let us put this down here. Put enter so that it's visible. Fine, so this is going to complete the round brackets are over. Yes, this is going to complete my sample data frame. Okay. Now, after creating this data frame, I'm going to re-index this with some different values. So let us write df equal to df dot reindex. Okay. Now, reindex can help me, assign the index values like previously we had index A, C, E, F, and H. So I'll now create more indexes. So I'll have E, which is already there, no problem with this, but I'll put B, and I'll put C, we had F, I'll put G and H. G and H. Okay. And now when I print the data frame, what one more thing we'll do is we'll print it here as well. So to show you the difference, df, and I'll just comment this for now. Let's run this. Okay, so here you can see this. These are my 3 columns, and these are my 3 rows, and these are the random values which were created using this rand_n function. Okay, now when I re-index this, there will be some changes happening. So I'll have multiple rows now. Now those rows which were not there, for which the random numbers were not created, will have the values. Cannot specify all the labels, index, and columns. Okay, there's some problem here. I have not put the square brackets. So when I give the re-index, please remember it has to be in the square bracket. Okay. Now I hope it comes. Yes, it is. Right. Now, if you look at this is my first original one, and when I re-indexed it for rows like B, D, and G, we had no values generated. So we have NaN. NaN means not a number. Okay. Now, if you have a database like this with you, and when you fetch all the records and store it in the data frame, and if you try to analyze such data, it will be very difficult for you, because if the values are missing, you won't be able to create a proper you can say analysis of the given data. Now, to handle such missing values, uh, pandas have 2 different you can say functions which are available, which will check whether the contents are there or not. The first function is your is null, and the other one is not null. Okay, so if I want to check it and replace that, if I want to fill that particular data, either I can fill it with some values, or I can also drop or remove those particular rows. Okay, there are 2 options with me. Now let us see the first one. If I want to fill it with some values, okay. So to fill it with the value, if the value is NA or NaN, then I have to make use of a function called fill NA. Okay, fill NA is a function which can be used. To continue with the same example, what I'll do is, now after re-indexing it, okay, uh, I'll check whether I have some values in it or not. So let us make some changes here, and after, instead of printing, or I can take it down. After re-indexing it, I can write, or let us print it first and then Yes, I'll remove this line. So I don't want this print statement here. I print this, and you can see any n, sorry, e small, and a not a number, replaced. Let us replace it with 0, replaced with, you can say 0. So 0. Now one more thing, if I want to include this, this has to be in double quotes. Okay. So I put colon as well. Now to do that, I can write print into bracket df dot fill any. That's the function which I'll be using, and I'll be replacing it with filling it with zeros. So let us see the content now. Okay, here we go. Now this was my previous data where we had NaN, and now you can see it has been filled by zeros now. Now zeros are not the only value which you want. If you have some other values also, you can include that. Like for example, if I want to fill it with 1, you can do that as well. Okay, or any other value if you want. Now, how do I check whether there are values which, if you want to make use of a function, for example, now before I actually replace, if I want to know whether a particular value is NA or it is NaN, okay, or is a null value. Now, as I told you, there are two functions. So I can write here print into bracket. Let us check the first column. So the first column is column 1. So I can write 1 here and use the function is null to check whether it is a null value or not. Okay, it is just going to give me true or false. So I hope I have given it properly. Df around square 1 we have.